In 1967, during one of the most turbulent periods in modern Chinese history, a young astrophysicist named Ye Wenjie witnessed something that shattered her world. Her father, a respected scholar, was publicly executed by paramilitary forces. From that moment on, Wenjie was marked, not for her brilliance, but for the political stigma of being the daughter of a so-called traitor. Left with no real path forward, she was forced into an isolated military research facility deep in Inner Mongolia. The base was remote, heavily restricted, and no one who worked there was ever allowed to leave. Cut off from the rest of the world, Wenjie buried her trauma and rage in the only thing she still had control over: science. At this hidden installation, she worked with a massive transmission array designed to send powerful signals into deep space. What began as routine scientific labor slowly turned into something far more desperate. Wenjie started using the array for her own experiments, directing humanity's voice into the cosmos, hoping, perhaps irrationally, that somewhere out there, someone was listening. Eventually, someone did. From a distant world came a chilling message, a warning, a plea. Do not respond. Whatever you do, do not answer. This eerie moment marks the opening thread of the story behind The Three-Body Problem, the groundbreaking novel that inspired the 2024-2025 global streaming adaptation, now reaching new audiences around the world. Celebrated by science fiction fans since the early 2010s, the trilogy stands out not just for its ambition, but for how elegantly it weaves together fields like physics, quantum theory, celestial mechanics, game theory, social evolution, and the philosophy of survival. It raises enormous questions about civilization, morality, and the place of humanity in a universe that may be far less empty than we assume. Without venturing into spoiler territory, the scientific foundation of the story, and the profound dilemmas it presents, pushes readers to confront unsettling possibilities about contact, coexistence, and the consequences of understanding forces far beyond our control. Alongside the trilogy's rising popularity, it's impossible not to mention how deeply it has reshaped modern science fiction discussions. The Three-Body Problem is only the beginning of Cixin Liu's sweeping narrative. Its sequels, The Dark Forest and Death's End, expand the universe into even more unsettling philosophical and cosmological territory. Together, these works form a monumental exploration of humanity's place in the cosmos, and the terrifying paradoxes that emerge when civilizations collide. The global screen adaptation of the series was developed by David Benioff and D.B. Weiss, best known for Game of Thrones, working alongside writer Alexander Wu. For many viewers, the project represents a significant opportunity for these creators to rebuild their legacy after the controversial ending of their previous series. The production team behind the adaptation includes major figures from across the entertainment world as well. Filmmaker Rian Johnson and actors like Brad Pitt and Rosamund Pike contribute to a project that aims to bring Liu's universe to a massive international audience. The original novel itself has already achieved legendary status. With more than 9 million copies sold worldwide, it has become one of the most influential science fiction works of the 21st century. Cixin Liu's reputation has grown to the point where he is frequently compared to giants like Isaac Asimov and Dune author Frank Herbert. Among his many honors is the Hugo Award, regarded by many as the closest thing science fiction and fantasy have to a Nobel Prize, previously awarded to authors like Asimov, Herbert, George R.R. Martin, and J.K. Rowling. But Liu's storytelling cannot be separated from the world he grew up in. The historical and political atmosphere of China during the 1960s left a permanent imprint on his imagination. Born in 1963, only a few years before the Cultural Revolution, Liu witnessed the shadow of that era shape nearly every institution around him. During the Cultural Revolution, schools and universities across the country were reorganized under radical political directives. Traditional literature and classical art were banned. Only state-approved revolutionary material could be performed or taught. Scientific research suffered heavily as well. Many academics were publicly denounced, stripped of their positions, or subjected to severe punishment for supposedly embodying Western capitalist influence. These historical scars permeate the psychological and thematic foundation of the three-body universe. Beneath its equations, cosmic mysteries, and philosophical conflicts, lies a profound reflection on what happens when knowledge, fear, and ideology collide in a society struggling to define its identity. Science fiction, like every form of art shaped by its era, was deeply affected during the Cultural Revolution. Anything that resembled Western influence or referenced pre-revolutionary culture was manned or destroyed. Cixin Liu, growing up in this atmosphere, inevitably felt the weight of those restrictions. Yet, as history often shows, oppressive environments sometimes give rise to extraordinary voices, and Liu would eventually become one of them. His fascination with the genre began almost accidentally. As a young boy rummaging through a dusty attic, he stumbled across Jules Verne's Journey to the Center of the Earth. It was his first real encounter with science fiction, and it ignited an obsession that would ultimately define his career. His debut novel, China 2185, marked his entry into the genre. That early cyberpunk-style story explored the idea of Mao Zedong being resurrected within a virtual reality world, a bold concept shaped by the political shadows of Liu's youth.
The same historical echoes would later become part of what inspired the Three-Body Problem trilogy. Anyone watching the adaptation or reading the books can often sense the residual tension of that era embedded in the philosophy, imagery, and emotional atmosphere of the story. Before diving into deeper themes, there's a question almost everyone asks at some point. Why is it called the three-body problem? The reason lies in a real, extremely challenging scientific puzzle. The three-body problem describes a physical system where three celestial bodies interact through gravity. Unlike the motion of two bodies, which can be predicted with near-perfect accuracy, the motion of three bodies becomes wildly complex, and in many cases, impossible to forecast long-term. Take our own solar system as an example. Today it might appear orderly and predictable, yet on a deeper level, it is inherently chaotic. Even with our modern models, the prediction horizon sits at roughly 100 million years. The system was first recognized as chaotic long before chaos theory was formally developed. Much of this understanding traces back to French mathematician Henri Poincaré. In 1887, he revealed that Newton's gravitational laws, while extremely accurate for predicting the orbits of two interacting bodies, break down in complexity when a third object is introduced. Pierre-Simon Laplace later expanded this line of thinking, proposing that the solar system was ultimately stable, with planets orbiting the sun forever on a fixed plane. But Poincaré's work exposed deeper instabilities lurking beneath that orderly surface. For centuries, scientists assumed that the solar system must remain stable forever, that the planets would continue tracing their familiar paths around the sun just as they always had. Under Newton's laws, this made sense. Two bodies locked in each other's gravitational pull can, in theory, orbit in perfect harmony indefinitely. The trouble begins when a third object enters the mix. That's where order collapses into chaos. The fundamental question behind the three-body problem can be framed simply. If three celestial bodies interact only through gravity, what will their orbits look like tens of millions of years from now? Even with modern computational tools, this remains nearly impossible to predict. In the late 19th century, the King of Sweden even offered a major scientific prize to anyone who could solve it. The award ultimately went to Henri Poincaré, not because he solved the puzzle, but because he proved that it cannot be solved. Working entirely by hand, performing calculations that would challenge even today's supercomputers, Poincaré arrived at a groundbreaking conclusion. The orbits of three mutually interacting bodies are fundamentally unpredictable. A minuscule change in one object's position, even one occurring billions of years earlier, could lead to entirely different outcomes. The future of such a system is governed not by simplicity, but by infinite possibilities. This inherent unpredictability forms the philosophical backbone of the three-body problem narrative. It represents the core tension that ripples throughout the story. As mentioned earlier, the central character establishes contact with an extraterrestrial civilization after transmitting signals deep into space. The world that responds is trapped in its own version of the three-body dilemma. The alien system, appropriately named Trisolaris, contains three suns. The instability of these stars drives the civilization's constant struggle for survival. In the adaptation, this concept is introduced through a virtual reality simulation in which players try to understand the fate of a planet caught between three competing gravitational forces. Inside this simulation, you aren't observing a simple solar system like our own. You're witnessing the desperate attempts of a civilization trying to predict a world that refuses to be predicted. And eventually, the unsettling truth becomes clear. This isn't just a game. Without venturing into spoilers, the narrative poses relentless questions. Which body orbits which? Is there any pattern at all? When cycles appear, do they repeat consistently, or are they just temporary illusions? Can chaos ever be forecasted? Can survival depend on understanding the impossible? These are the mysteries at the heart of Trisolaris, and they shape the fate of everything that follows. The unpredictability of the three-body problem shapes the destiny of the Trisolaran world, and the struggle between order and chaos becomes the defining force behind their civilization's survival. The solutions they pursue, desperate, radical, and morally complex, end up influencing not only their own future, but ultimately ours as well. This is why the three-body problem stands apart from classic first contact stories. Instead of aliens suddenly appearing above our cities, like in Independence Day or War of the Worlds, the trilogy explores the idea of contact as a slow-burning, intellectually haunting process. It's not a simple invasion story. It's a clash of philosophies, physics, and survival instincts. One detail worth noting while watching the adaptation is that several characters were created specifically for the series. Even so, these new additions often embody aspects of multiple characters from the books. You'll also see a core group forming around the aftermath of Ye Wenji's traumatic past, a group the show frames as the Oxford Five. Among them is Da Shi, one of the characters who remains closest to the spirit of the original novels. Through these characters, the series explores gravitational anomalies, first contact dilemmas, and the broader philosophical questions that Stephen Hawking once warned about. Hawking famously pointed out that throughout history, encounters between advanced civilizations and less advanced ones rarely ended well for the weaker side. His concern, echoed in the themes of this story, was simple. When a highly advanced civilization arrives, intentions matter far less than power. This raises a question that goes beyond the show itself. If a technologically superior and potentially hostile civilization began moving toward Earth, how would humanity react? What choices would we make when confronted with forces far beyond our control? These are the questions the narrative pushes us to confront. The series dives into these ideas through a storyline woven with time jumps, shifting perspectives, and multi-layered revelations. For years, many believed the trilogy was simply too complex to adapt, its scale too large, its scientific backbone too dense. Yet somehow, it finally found its way to the screen. Of course, not every creative decision aligns with the books. The show takes notable liberties, drawing from all three novels rather than sticking strictly to the first. Even episode titles contain references to later volumes, such as the concept of Wandering Earth, which originates from the second book. Fans familiar with the entire trilogy will recognize the many reinterpretations and expansions. The adaptation also leans more toward thriller-like pacing, compared to the deeply technical and philosophical nature of the novels. Some viewers appreciate this shift. Others feel the scientific detail has been softened. Ultimately, expectations shape the experience. You may also notice visual and thematic nods to works like Oppenheimer and 2001, A Space Odyssey, choices that some argue reflect a desire to give the story a broader, more international tone. While the original narrative unfolds almost entirely in China, the series places much of its action in London, making it feel more global to modern audiences. It's also worth remembering that this isn't the first adaptation attempted. Earlier Chinese versions never reached wide international visibility, nor did previous film efforts fully capture the scope of the novels. The involvement of high-profile Western producers brought the story to a global stage for the first time. Whether the adaptation succeeds depends on what each viewer brings to it. But regardless of your expectations, it's rare for a hard science fiction epic of this scale to reach such a vast audience. For that reason alone, it's a project worth experiencing. If this breakdown has helped answer some of your questions, then the journey has been worthwhile. The series will continue to spark debate as more people discover it, and the conversation is far from over. If you enjoyed this analysis and want to explore more stories like this, make sure to subscribe to the channel and join us for the next deep dive into the mysteries of science, history, and the unknown.